Hi, good afternoon. We are going to present you our experiment about equilibrium, and my team is conformed by Edsel, Diego, and me, Jesus.
Well, the objective is to know how to solve the problem and to explain how this works, the tension and the equilibrium of the forces.
And to this experiment is related the first Newton's law, which establishes that any object that remains in uniform motion will remain in the same state unless it's acted by an external force. Likewise, a body is considered to be in static equilibrium when initially at rest, persists in the state of rest.
And for this project, we're going to need a wrench, a teaser, and two weights of 5,000 grams and one of 1 kilogram.
Well, first I'm going to explain what is this. Our data was to have left and right is 45 degrees. Here we can see that it has an equilibrium between the forces. Here is tension number 1 and tension number 2. And these forces are equal to 0 because it is resting, it isn't moving until another force push it or move it.
In order to solve the next problem, we're going to use two different formulas. We will use this one to solve in the x-axis, and we will use this one to solve in the y-axis. So, first of all, we're going to solve for tension number 1. As this is multiplying the tension number 1, it will pass dividing out the sum of all this. Then we're going to multiply it times the sine of the tension 1 plus this one. And the next step is, as these two are the same data, we will divide them out, and we're going to have tension 2 times sine of 45 degrees plus tension 2 of sine of 45 minus 4.9. Then the next step is, as these two data have the values, we're going to sum. So it's going to be 2 sine of 45 equals to 4.9. So as the sine of 45, 2 sine 45 degrees is equal to 1.41. And our last step is to solve for tension number 2, which will be 4.9 over 1.41, which will give us the value of 3.48 newtons when we have the weight of 5,000 grams. And for the 1 kilo weight, we're going to have the values of 6.96 because it will be the same data but multiplied by twice.
Let's multiply it twice.
As a conclusion, we found out that it's better to find equilibrium when you have, well, the degrees are the same as when they are different.